Okay, so another force problem here, net force problem. And so first of all, what do? Free body diagram, right? Oh, let's get that started. So we have a box. So we'll just draw it as a nice simple box. We're told that one student pushes on this side, and so we could say that's 100 newtons there, and the other pulls in the same direction, so 60 newtons there. And then we have a friction force, so that would be in the opposite direction there. And we're told that they're unable to budge this box. So what does that tell us? Well, that tells us that if the box isn't moving or changing its motion at all, then the net force must be zero. So let's get started with this. First of all, the net force is zero. And so let's start plugging some things in. Now, first of all, before we get started plugging it in, let's make sure we decide which way is positive. I think I'm going to say to the left is positive. Everything's kind of getting pushed that way. And so let's make that positive. Always good to mark that down, just so you remember, so you don't get to the end and get a little confused. So carry on. If the left is positive, that means that the 100 newtons is positive. It also means the 60 newtons is positive. And that means that the friction force is a negative. So we can do one of two things. Is we could say plus FF and it'll come out to be a negative in the end. Or we could write minus FF and already look after the negative right up front here. So either way is fine. You can try it either way and see which way makes the more sense to you. I'm going to put the negative right in there to start with. But when I get to the end, I'll have to remember that I already accounted for the negative. Okay, so let's carry on here. If we were to rearrange this, we can move the force of friction over to one side and we're left with 160 newtons on the other side. Now, we always consider that when we come up with an answer in a vector-related problem, like forces are vectors, right, is we always have to have a direction. So the force of friction is 160 newtons. And which direction is it? Well, we already considered it as a negative. In other words, we already said we know this is going left, or know this is going right, sorry. And so basically going the opposite of what we considered positive. So when we come up with a positive number at this point, we know that we were correct. So this is definitely right. Now, had you put positive FF in there, you would have said, I didn't know the direction, so I just left it until to find out the direction at the end. No problem. You would have just ended up with a negative, and then you would have went back and you would have said, oh, well, I considered left to be positive, so if I came up with a negative, it's going to the right. And that is a great way to do it as well. So either way, just say, I'm not even going to bother guessing. I'm just going to put it in as all these vectors positive, the positive force of friction in there, not judging which direction it's going at this point and finding out at the end. Or two, if you say, oh, I know which way it's going to go, I might as well just throw it in there into the equation and I'll be confirming at the end when I have right and everything comes out positive. So either way, perfectly good. The answer here, we have the magnitude, we have the direction, so we do have a good answer for a force problem.